Okay, the next question we are doing is question 7b. Okay, so we got to normalize a floating point number. Okay, and this time, it's the same questions but a different part. So we're using 8-bit mantissa and a 4-bit exponent. Okay, and our number is 1.1110011, and our exponent is 0011. Okay, so now just straight off the bat, with this does not look right. That's not normalized. Not normalized. That's not normalized. So we need to make an adjustment, and because this is negative, we know that the pattern that we're aiming for is going to be 1.0. Okay, so we need to move the binary point so we get to that position. So we're going to do that now. So let's see, didn't want that, too slow. 1, 2, 3. So that went to, that was plus 3. That would represent, because we made that binary number bigger by moving the decimal point to the right, so that's why it's plus 3. Okay, and this exponent represents 2 times 2 to the power 3, because that's 1, 2, and that's going to be 4. I'll put minus C, and so that's what that exponent represents. Okay, so now using my method, so this plus 3 2 to the plus 3, so that's going to, so we need to combine these two powers. So that existing one is 2 to the 3, and then we're going to also put this. Now to normalize it, we did plus 3, we made it bigger, but in the exponent, which is to adjust it back to the actual number it was, that's why we flip it back to a minus 3. This arrow is a bit misleading, so I'm going to rub that out. Oops. Right, so this is where that came from, and that is where this came from. Okay, right, and then so using our powers, rules of indices we learnt from GCSE maths, that's going to be 3 minus 3, because it's 2 to the power a times 2 to the power b is 2 to the power a plus b. So that is 2 to the 0. Okay, so that's what our exponent of our normalized number will be 0. Okay, so let's write this out. Okay, so with that binary point, it's going to be 1.0011, and we need 8 bits for the mantissa. That's 1 nibble, so we need that, and that's our mantissa, and our exponent is going to be, strangely, all zeros. Okay, right, that's our finished question. Oh yeah. Just as a reminder, do not put not in final answer. The binary point is not stored in the computer. It is assumed to be in that position for floating point numbers.